You know, when you think about the bottom of the ocean, the crushing depths, the absolute darkness, you probably picture things that are, I don't know, ghostly and tiny.
Translucent, almost fragile things.
Exactly, fragile. But then the deep sea just throws out a true surprise, something that just completely upends that idea.
Which is why the sheer scale of Alicella gigantea is so fascinating. Today, we're doing a deep dive into the largest known amphipod, a supergent crustacean that can reach up to 34 centimeters.
That's 13 inches long, a 13-inch super shrimp. That's just massive for its kind.
It is.
Yeah.
Our whole mission today is to unpack the source material and really understand how this creature thrives in Earth's deepest, most extreme environments.
Right.
It lives in the abyssal and even the hadal zone, so we're talking trenches, anywhere from about 4,800 to 7,000 meters down.
And what's so striking is its color. It's just white.
It is. Most deep-sea animals are red or orange, to hide.
Yeah.
But A. gigantea is this giant albino of the deep, which probably suggests it just doesn't have many visual predators to worry about down there.
Okay, so let's unpack the history a bit. The species was first documented way, way back in the 1890s off the Canary Islands.
That's right, by the expedition ship Princess Alice, which is, of course, where it gets its genus name, Alicella.
Can you just imagine the surprise of those researchers pulling up a specimen this big over a century ago?
Oh, absolutely. And here's where the science gets really, really interesting. A. gigantea is just a classic case of what we call abyssal gigantism.
Abyssal gigantism. So what's the theory there?
Well, the hypothesis is that the frigid temperatures and the immense hydrostatic pressure, that's the weight of miles of water, it slows down metabolism.
So everything just happens in slow motion.
Exactly. This leads to these unusually long lifespans, probably over 10 years. They just keep growing because their life cycle is so dramatically extended.
So the pressure doesn't crush it. It fundamentally changes the way its biology works. And this size isn't just physical. It's written into its DNA, right?
That's right. The sources mention an exceptionally large genome, around 34.79 gigabase pairs.
What does a number that big even mean for us non-geneticists?
I mean, for context, that is gargantuan compared to most typical invertebrates. The leading theory is that a whole genome duplication event occurred in its past. Basically, it doubled its own instruction manual.
Which might have given it the genetic flexibility to get this big and handle that environment.
Precisely.
You know, analyzing a genome that enormous, finding that specific genetic event that requires some serious computational horsepower and high-level data processing.
Oh, the amount of data is just staggering.
And that's where really efficient solutions become critical. I mean, if you or your organization is wrestling with complex data, maybe needing help with AI training, automation, or software development, you should check out embersilk.com for your AI needs. They specialize in uncovering where AI agents can make the most impact for your business. That's embersilk.com.
Right. But let's get back to the ocean floor.
Yes.
What's fascinating is its distribution. Even though we rarely see it, recent studies suggest this species is cosmopolitan. It could potentially inhabit 59% of the world's oceans.
59%. That completely reframes our understanding. So the deep trenches aren't as isolated as we thought.
Exactly. Genetic studies confirm there's significant gene flow across all these different populations. It shows the deepest zones aren't just scattered pockets of life.
They're more like an interconnected highway system.
A highway system, that's a perfect analogy. It allows these incredibly resilient organisms to spread globally.
And what about how they live? I understand the adults are scavengers.
That's right. They're primarily scavengers. They use their huge size to feed on carrion that drifts down, like a whale fall. Juveniles, though, they start smaller on bacteria and zooplankton debris.
Speaking of bacteria, I saw that these hadal amphipods have large amounts of beneficial, almost probiotic gut microbiota. Why would a deep-sea scavenger need good gut bacteria?
Well, that's a critical point for survival. In an environment where food is so scarce and intermittent, you might be waiting for one large meal to sink. Those gut microbes help them process food incredibly efficiently.
Maximizing every last calorie.
Exactly. Maximizing energy extraction, ensuring resilience in that high-pressure, low-nutrient world.
So if we connect all this to the bigger picture, the vast reach, the genetic complexity, and just the sheer resilience of Alicella gigantea, it really proves that life finds a way to flourish, even in what we consider the most hostile corners of the planet.
It really does. This one species shows us that the unexplored deep ocean is a dynamic, interconnected system just waiting to reveal its secrets.
So what does this all mean for you listening? Well, consider this. If a creature this large and genetically complex can thrive in the most extreme, lightless trenches on Earth, just imagine the incredible biological breakthroughs that are waiting for us as we continue to explore the other 41% of its potential habitat. That's a whole universe of discovery waiting right below us. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.